Hello, algebra friends. Welcome to Algebra Online. Here's a little comic for you. I think hopefully we're over the hump and maybe we'll move on to at least spring, but not summer. This video is going to take a look at outliers and percentiles. Let's start on your notes, page 16, and look at an outlier. So this is something we've talked about in the past, and also you hear this term all the time. So what technically is an outlier? Well, an outlier is a piece or pieces of data that are significantly far away from the other data values. And the technical calculation for an outlier is that it is 1.5 plus or minus the IQR. If we do a box and whisker plot, we usually put it on there with an asterisk. So we'll talk about actually how to do this in a moment. Here's an example for you to show how an outlier can affect your measures of central tendency. So the following shows the quiz scores of 15 students in Mr. Magoo's algebra class. In the second list, the score of 65% was replaced with a 0. Both sets have the mean and the median calculated. So as you can see, there's a drastic drop in the mean with that 0. Here, the median and the mean are pretty close together. And here the mean is definitely considerably below what the median is. In the second set, 0 is called an outlier because it is significantly far away from the majority of the scores. What impact did changing the 65 to a 0 have on the median? Well, it didn't have any. The middle score is still the middle score. What impact did changing the 65 to a 0 have on the mean? Well, that dragged it down 5 points. Which measure of central tendency, the median or the mean, best describes the overall scores of the class? So although there was 1 0, most of the students scored well into the 80s. So the 84 is a better measure of central tendency. If the set has outliers, the median is definitely a better descriptor, and with no outliers, the mean is a better descriptor. Just to explain how to actually get that outlier, you will work on page 22 in your practice packet. What we do is we take the box and whisker plot and we figure out what the interquartile range is. Then we multiply the interquartile range by 1.5, and then we add and subtract that number from quartile 3 and quartile 1, and that represents the fences. And the fences are the data points that the value would have to be above or below. You will see that term referred to when you're doing some examples. A quick note on a quartile. So remember that a quartile is a number. It is not a range of values. A value can be described as below or above the first quartile, but it's never in the first quartile. So again, when you're figuring out your outliers, quartile 1, you will subtract 1.5 times the IQR to get the fence. So let's say quartile 1 was like 38. And I don't know what your IQR was. Let's say it was 10. So I would subtract 15 from 38, and that gives me 23. 23 is going to be the fence, so anything below a 23 would be considered an outlier. Okay, now let's take a look at percentiles. So whereas quartiles divide a data set into 4 equal parts, percentiles divide a data set into 100 equal parts. And you've heard this term percentiles before. It measures position from the bottom or the lowest. It gives a rank, and it tells what percent of the total frequency scored at or below that measure. Now, this is going to be important to show how we actually figure out a percentile. If you were in the 80th percentile, 80% of the students scored at or below what you scored. So this is not in your notes, but let's just read through it together. The percentile rank is a number between 0 and 100, indicating the percent of cases in a group falling at or below the score. Percentile ranks are usually written to the nearest whole percent. Scores are divided into 100 equally sized groups. Scores are arranged in rank from lowest to highest. There is no 0 percentile. This lowest score is the first percentile, and there is no 100th percentile. The highest score is the 99th percentile. You cannot perform the same mathematical operations on percentiles that you can with raw scores. You cannot, for example, compute the mean of percentile scores because that could be misleading. So here's a couple examples just to explain how it's used. Carl takes the earth science test. His teacher tells him he scored in the 92nd percentile. Is he pleased? Yes, he should be. He scored above 92% of the people taking the test and below only 8% of the people taking the test. Sue takes the Chapter 4 math test. If her score is the same as the mean for the math test, she scored at the 50th percentile and she did as well or better than 50% of the students taking the test. If Ty scores at the 75th percentile on the social studies test, he did as well or better than 75% of the students taking the test. This is also not in your notes, but it's going to explain how to find percentile. So if you want to copy down these scores and work with me on it, you're welcome to. You pause here and do that, or you can just watch along. Here we have 20 math test scores, and we want to find the percentile rank for 84. So what we're going to do is we list them in order, and then we find the 84. Now notice there are two 84s. So we're going to group up all and including one of them, and that is 9 of the scores. And remember, our n is 20. So we basically just do a quick calculation of part over whole, and 9 over 20 is 45%. So the score of 84 is in the 45th percentile. Now where it gets a little bit sort of confusing is because there are two 84s, I take one of them. If there were three 84s, I would have to split the 84, the middle one, down the middle. So that's going to look like this. Let's say we wanted to find the percentile score of 86. There's only one 86. So because of that at or below definition, we're saying, well, the 86 kind of pertains to the lower half and the upper half at the same time. So if we were to count up these scores, we would get that it's 11.5. We're not going to count that as 12 because it's at or below. So we're going to just split that 86 in half and say 11.5 are at or below. And out of my 20, that's going to give me a percentile rank of 57.5%. Okay? And you're going to get some practice with this in your packet. You can refer to the schedule and take a look at the pages that pertain to outliers and percentiles, and we can check the answers later. Have a great day.